Hey guys, welcome back to a new video of the Spring Boot 4 Basics with Kotlin playlist. In this video, exciting stuff will happen because we will implement our very first persistent SQL database that we connect to our backend here. In the last video, you've already learned how request validation works with Spring Validation, that we can just annotate our fields of our DTOs in order to automatically apply validation and to reply with proper status codes. Now in this video, we will migrate our currently purely in-memory quotes repository that stores quotes in a list of the normal Kotlin list here after all. We will migrate that to a real repository that really stores these quotes persistently, and these will therefore also survive server restarts. And in case you don't know me, I'm Philip, and since 2019 I'm doing nothing else than developing software with Kotlin. So if you want to learn more about developing with Kotlin for the full software stack with over 1,000 videos, then make sure to subscribe to not miss any upcoming ones. Let's dive right into it. When it comes to persisting data on Spring Boot, like our quotes here, then there are a lot of different ways to do that. However, regardless of where you learn about Spring Boot development, you usually don't get around what we call JPA, the Jakarta Persistence API. And that is in the end a library, a framework that allows us to treat our Kotlin classes as database tables. And the library then simply abstracts most of the necessary SQL that would have to be executed behind the scenes. So we really mostly just write Kotlin code here, define how our DB works, how our DB looks like, which tables we have, how these may be connected. And the library then takes care of the interaction with the actual database, with the actual real SQL instance. If you maybe have an Android background, which is likely if you're a Kotlin developer, then JPA will really remind you on Room, so a very common database framework for the Android side, because on both these frameworks, we define how our DB looks like simply with annotations. And before we actually get into the coding part here and really use JPA in order to persist our quotes, I want to leave a few words about which persistence API to use, because as I mentioned, there are so many different persistence libraries that allow us to connect to an SQL or NoSQL database from Spring Boot, and JPA is definitely at least debatable, and many developers debate about that, whether you should use that, whether not to, because a big thing here is of course always the less code you have to write to achieve something that possibly bears a lot of complexity behind the scenes, like a complex SQL query, the more magic is also typically going on behind the scenes. So the more of these complex queries the library is generating for us. And the more you as a developer let happen behind the scenes, the more potential there is probably also to fine-tune in these queries. So by using JPA, it now could be that not all of your SQL queries are 100% optimized. Don't get me wrong, that doesn't mean that the queries it generates are bad. This is really an industry standard library, but they are simply generated, which gives us a type-safe interface for it. And I would say using JPA is definitely the easiest entry point for people learning Spring Boot, for people who want to now also build and implement databases in here. What is important to mention here in a Kotlin context is that JPA is a Java library. So that was originally written in Java, which is not a problem. We can use Java libraries in Kotlin. But what this means is it only supports asynchronous programming via typical traditional threads. It does not support something like Kotlin coroutines, which is a pure Kotlin feature. If you want to work with coroutines in your Spring Boot backend and you have some sort of database you connect to, which is almost always the case in a backend environment, then you would instead have to stick to a so-called reactive database driver, where I can personally recommend the library or the framework Jooq, so Jooq, which however is a lot more complex to set up and to use, because it doesn't so much rely on annotations, but rather on you defining which specific queries you want, but in a type-safe fashion in Kotlin. But either way, just using normal Spring Boot with a normal threading in Kotlin is still something that is very typical in Spring Boot development, and also doesn't mean that you will have a bad performance or so just because you can't use coroutines. Coroutines would just make it a bit easier to have asynchronous calls, but won't have a life-changing impact on performance. Long story short, if you're new to Spring Boot with Kotlin, you've never worked with an SQL database in here before, then stick to JPA, start with that. And over time, if you feel like, hey, I want to try out something new, then take a look at other frameworks. The first thing we need to do before we can even type some database-related code is we need a real database to connect to, because that's the typical way it works, that in our Spring Boot project, specifically in the application YAML file, which you've already learned about in one of the previous videos in this playlist, here we typically define the configuration and the setup for our database so that we automatically connect to it. In order to do that, we first of all need to add the necessary dependencies in our Gradle file, so that our Spring Boot backend and the IDE knows which framework we want to use, that we want to use JPA, that we want to use, in our case, PostgreSQL, so just little Spoiler here, we will use PostgreSQL and connect to a Supabase instance. So let's first of all jump into our build.gradle KTS file, because this is where we add all these dependencies we need in the project. Sometimes IntelliJ marks these as errors, but after a sync, this should be fixed. Let's go here after having defined our 3 Spring Boot starter dependencies already. The validation one is there. That is one you've already learned to use these dependencies here in Gradle with. We on the one hand want to duplicate that and add the Spring Boot starter-data-JPA dependency here. This will really add the JPA framework together with what we call Hibernate. So Hibernate is a specific implementation of this API, of this Jakarta persistence API. And additionally, we need a dependency that adds the necessary database drivers in order to connect to a PostgreSQL instance specifically. So in case you're new to SQL databases, SQL isn't just SQL, but there are different so-called dialects or different versions of SQL. So MySQL, PostgreSQL, MariaDB, all these have their own kind of dialect where the core is really just SQL and is the same, but each having different types of features, being better for certain use cases than the other. And in our case, Supabase is based on PostgreSQL, which is super viable and super established. Here we want to say runtime only, because that driver dependency is only needed during runtime. And we say org.postgresql. You can see it suggests that already. That is the dependency we want to add here as runtime only, the other one as implementation. And then we click this button to synchronize our changes. And after that, we will be able to start using JPA with PostgreSQL. After that sync was successful, we now need to set up our actual database that we connect to. And that typically works via so-called connection strings. So you either have the option to really define each and every part that is needed in order to let the driver kind of log into your database. And that really doesn't matter if it's a remote database, a cloud database like here with Supabase, where Supabase hosts that database instance for you, or if you have a local database running on your local machine, you would still have some kind of URL to connect to, which in that case would be localhost. But if we go to Supabase, that's of course now where it makes sense for you to register an account if you want to follow along. So really just go to supabase.com here. This is pretty clear. I think if you are learning to develop backends, then you will be able to register an account here. There will be some sort of button to start your project, create your account, just enter your details. And the moment you've registered there, Supabase will ask you for 2 things. On the one hand, your organization, or whether you're an individual or so, you just enter your details, obviously. And on the other hand, it will ask for some details about the database that you want to create. On the one hand, the server location, so where this database should be hosted, makes sense to choose something that is close to you, to where your users are, to remove, not remove, but to reduce latency. And it will ask you to create a password for that database. That's of course important. Keep that password somewhere, because we will need it in this video. And after you've then created that project, so each database in Supabase is part of a specific project that is very typical for these cloud-based solutions, then it will look something like this. So my project is called YouTube, and this is really just a completely fresh instance of an SQL database that we can now connect to by clicking on this connect button. If we click here, and we then click on this type here for this URI, so there are different types of URIs of connection strings depending on what you use to connect to this DB. In our case, we will use JDBC, that is the Java database driver or so. It's in the end a database driver, Java-based, that will under the hood connect to our database and talk to it. If we select that, then this is the string that we are interested in. So we copy that, go to our Spring Boot backend, and we now need to set up these connection details here in our application YAML file. Whatever type of DB you connect to, the settings in Spring Boot are typically here under Spring data source, and then here, for example, let's first of all say data source URL. That is, for example, the application YAML parameter where we can pass what we've just copied, which will then tell the database driver where to connect to. This will of course differ for your DB. Here it's important that you have this JDBC prefix, and then you can see technically this URL contains all the details that are necessary in order to connect to this DB. It includes the database name, which by default is Postgres. It includes the username, which also by default is Postgres in Supabase at least, and a password, which hasn't been substituted here. Since we don't want to put the password here in plain text in our application YAML file, which would also be pushed to version control, so we really don't want to keep such secrets in version control if you've watched the video about profiles and such environment variables. What we instead want to do is we get rid of the password here, and maybe even get rid of the username, and we instead specify these as separate parameters here to just keep this a bit more readable. On the one hand, the username, that is not sensitive. Here we can just choose Postgres, what this was here before as well. And the password, well, that is something we don't want to put here in plain text, as I mentioned, but rather specify and pass this from our environment variables. So we say we substitute this from a placeholder that comes directly from environment variables, and we give it some kind of name like Postgres password. And then we, of course, have to add this password in our environment variables as well, which we can do here for our run configuration. Again, probably depending on whether using IntelliJ Ultimate or the Community Edition. In Ultimate, you will have this environment variables here as your run configuration, or you would need to go to modify options and turn this on. But I think in the Community Edition, environment variables should also be able to be passable here in this run configuration. Here we still have some of these variables from the previous videos. Let's just leave them. But we would now add a Postgres password. Make sure to spell it exactly like the you did here in the application YAML file, and then you simply paste the password in here under value. After having done that, we click OK, hit OK, and now we have added almost all the details we need in order to connect to the DB. One more thing is we need to specify the driver class name, so the actual class name of the driver that will connect to our database instance, and that is our PostgreSQL driver. So we specify org PostgreSQL.driver. That is just a class that comes from our PostgreSQL dependency and is able to now connect to our string. And I would say with this information, we jump into our Kotlin code and start defining our database table, because SQL databases are table-based. So we have tables with clear columns where each column would be some sort of type of data you would want to save. In the context of our quote, that would be an ID, the content, and the author. And then each row of our table will be one specific quote with one specific piece of content and one specific author, and of course, one specific ID. So if we go in our root package and we create, actually not a new package, but a new class, we create what we call a quote entity. So entity is typically the naming that is established when it comes to having classes, Kotlin classes, that represent a database table. So here it would be nothing else than a quote table in which we define how our database table should look like, where we want to save some quotes. So just like with our quote DTOs, where we have a Kotlin class that is optimized for exchanging and parsing that over the network, so parsing this to JSON and from JSON, here we have another type of model for a quote that is optimized for saving this in a database table after all. And what is now important here for JPA entities, so table definitions in form of a Kotlin class, don't use data classes here. Data classes actually are special classes in Kotlin that I would usually prefer when it comes to bundling data inside of a class and having a class that is purely meant to bundle such data like content, author, and so on. But it also comes with additional overridden functions that you don't see at first, like it overrides the toString function, the equals function, the hashcode function, and also provides an additional copy function that normal classes don't have. Usually that's quite handy, but these additional overridden functions, specifically the equals and hashcode function, can under the hood, under certain circumstances, lead to issues with JPA. It hasn't happened to me specifically, but I've heard people having issues with that. So the safer approach here when using JPA with Kotlin is to just use normal classes that don't have these extra overridden functions from data classes. The first thing when defining such a JPA entity is to annotate this, well, with entity. Alt enter to import that. Additionally, what we want is we want a table annotation. So we really have an annotation that defines this as a table in our database. We give this a name, for example, quotes, that will be the name of our tables. And then we can give this class a constructor. And now the variables we put in here are really nothing else than the actual columns that we will then end up with in our DB. Every single SQL database table definitely needs a primary key, so a primary identifier that must be unique. So you can't have two rows where both have the same primary key. That is not possible unless you have a combination of primary keys. So primary and secondary key it would be then, but that's more advanced. Typically your primary key is just called ID. So we want to have an ID here, and this should be a var. And the most simple type of ID would be a long ID. You can also make this a UUID, for example, as long as it's really unique across rows. What also makes sense here is that we let JPA auto-generate those IDs, so that we don't always need to think of really generating these IDs, of having unique IDs when inserting a new quote, but just hand that over to the DB. That is typically what you do, and we achieve that by setting this equal to 0 by default, then annotating this with ID to really tell JPA, hey, that is our primary key column. Alt enter to import ID here from Jakarta persistence. And additionally, we want to annotate this with a generated value. This annotation here is optional, but can be used if you want JPA to generate these IDs for you. And then it will simply automatically increment these values the more quotes you insert. So Alt enter, import that. And for this generation, you can then choose a specific strategy, which in this case makes sense to choose identity. In this case, it will simply auto increment that value. Another strategy here would, for example, be UUID. Then JPA would generate unique UUID values if that would be the type of your primary key. Other than that, what we want to save for a quote is, of course, the content, which is a string. And we can set the default value to an empty string, and the author as well, which is also a string in our case, an empty string. For all these normal columns, which aren't the primary key, but just normal columns, we need to annotate these with column. And here we need to specify, hey, is this actually a nullable field or not? Even though in Kotlin we have nullable types, and this would clearly be a non-nullable type here, we would still need to specify this, since in Java, nullable types don't exist, and every class instance could technically be null in Java. Same thing for the author, that's also not nullable, and that is technically already our entity class. That would be enough in order to create and work with this table. Other cool things that you can do here with JPA is to have something like a creation timestamp. Alt enter to import that, and then you say, okay, we have a var created at, for example, which is a Java time instant, and you set this to instant at now by default. Then JPA will automatically assign the time where this quote was created additionally to this table. Same thing exists for the updated timestamp, so whenever you make any changes to that specific row, then JPA will keep this field updated. So now we have our table definition. Now JPA knows how our table looks like, which fields it consists of, how these fields are set up, if they're nullable, not nullable. Technically, you can also say, hey, this is maybe unique. If you have a user, for example, and the user has a unique ID, but maybe you also save an email and you want to make sure that emails are unique in your DB table, then you could set this unique constraint here additionally, and the DB will verify that for you. But additionally to defining what our table looks like, we of course also want to define how we want to interact with this table specifically. And that is what our repositories are responsible for. So while in our quotes repository, we currently just maintained an in-memory list of quotes, which did its job as long as our backend was running, but the moment we of course relaunched it, this quotes list was empty again. That is what we now want to change by really persisting our quote entities in our remote Supabase instance. So what we can do is, we can really delete all of that. With JPA, we don't need to specify any specific database logic on our own unless you're working with more complex queries. You can even get rid of the repository annotation, and we need to make this an interface because JPA works with interfaces for every single repository that you have. So you typically have one repository per table in which you define how you want to interact with this table. So which queries you, for example, have that you want to run on this one. To make this a JPA repository, you need to make this implement the JPA repository interface. Alt enter to import that. And then here as generic arguments, we have two of them. The first one is the type of entity we want to save in this repository, which is quote entity. And the second argument is the ID, so the type of the primary key we're working with here, which are long values like we've specified here. And well, now by default, just having done that, just having a quotes repository specified that it's a JPA repository and which table it's for, that's already enough that this JPA repository gives us so much functionality that we can run on our DB for common things like saving new values, upserting values, finding all elements, all quotes in this table, finding a quote by ID. So these very common queries that you need all the time are already predefined here in this JPA repository. I think it's a class. If we command click into that. Oh no, it's actually interface, but there is functionality inside this interface. And Hibernate is then what brings the explicit implementation of this interface. So if you see Hibernate logs later on, then this is in the end JPA. So if we now go to our quotes service, the service layer in a Spring Boot project is typically what interacts with your repository. Here we also have our quotes repository. But now that we've actually removed our previous functions, we get a lot of errors, of course. When getting quotes, we can now say, okay, that should actually return a list of quote DTO again. And we would say, we return quotes repository And here you can see a lot of these functions already come from JPA, save all, find by, find by ID, delete by ID, all these kinds of calls that are very interesting, and most of these we can really just use as they are without having to define anything inside this interface. So we can say quotes repository find all, and now, well, what this quotes repository find all returns is a list of quote entities, because that is the type of our DB model, but we expected a list of quote DTOs. And this is why we typically work with so-called mappers in Spring Boot. So if we have the same model, but two different types of that model, so once for the DB, once for the network communication, but in the end, both of that represents a quote, then we create a mapper, so nothing else than a function that takes an instance of one class and maps it to another. So it just returns the other instance. And that we can create in our service layer by saying quote mappers, make this a normal file, and we say we have a function that extends a quote entity, and in the end converts this to our DTO. Returns a quote DTO, and now we just need to say what or how we need to take the data from the entity in order to create our DTO. So ID would stay our ID, the content stays this.content, and the author also stays this.author. In our case, our models are identical, but that's really not always the case. Sometimes what the API responds with to the client is very much different than what you save in the database. For example, if you have a database table that saves users, and for these users, you save certain passwords of them, ideally in a hashed fashion, then this hashed password string is still something you wouldn't typically respond with to your client, because the client wouldn't be able to do anything with that. In that case, you could simply omit this field in your quote DTO, but you would still keep it in your entity in order to then match an entered password with what you have saved in your DB. The same way we can map a quote entity to a quote DTO, we can also map it the other way around. So a quote DTO to an entity. So quote entity here and quote entity here. So this is of course bidirectional. And by having these mappers, we can now go back to our service layer, say map here. So we want to map each element of this return list of quote entities. And we simply say, hey, every single one of them, we want to instead map to a DTO. And suddenly our error is gone. So this really just takes our list of quote entities and maps it to a list of DTOs. When inserting a quote, it should also return a quote DTO. So here we would say quotes repository, and we save a new element. So save is a function that will insert the quote if it doesn't exist. So if we pass a quote with an ID being equal to 0, then like we've specified here, it will simply generate and auto-increment the last ID of that table. But if we pass a quote with an ID that already exists here, it will upsert that instead. So it will find a quote with that ID and then update all the remaining details with the details from the quote we've passed. So that would look like this. We have a save function. We then say quote. Here we now have our quote DTO we get from the client. And we need to convert this to an entity that our DB understands. But the save call then returns the entity that has been that was inserted in our DB. And that is now something that we again want to convert back to a DTO. So we say that to DTO. So we can respond with the final quote that has been inserted in the DB to our client. What's important here for this insert function is that we really make sure that this entity has the ID 0 being assigned, because otherwise JPA will complain that the ID either doesn't exist, that it would then try to update, or it would update an existing quote. So we want to call that apply, and here we say this.id, set this to null, 0. So regardless of what kind of quote we pass here with an ID, we always make sure it's 0 before we insert it in our DB. Alternatively, you could of course also go ahead and say you define a separate create quote request for the client, where the client can't even specify an ID in the request, because the client wouldn't need to set this from the outside anyways, for creating a quote at least. That would be what I would normally pick, but yeah, it would require a separate class here, separate validation, and so on. The same thing can then be done for updating a quote. Just that we here don't update the ID, because we explicitly want to upsert this quote where we already have an ID, and that is the quote with the ID that we want to update. So save here in this case will automatically detect that. Okay, quote exists, let's update that. And deleting a quote, well, for that we also have a function, quotes repository, delete by ID, and we pass the quote ID here from a parameter. And this is now how the interaction with JPA would look like. You can see we don't have to define anything inside this repository, and we can already have very fundamental, very basic CRUD functionality. So create, read, update, delete. Now I know you're very curious what we could put into this interface here. to, of course, also define some more custom queries, and we will get to that. But I first of all want to test what we've actually built. So I have our service, and I think in our controller we should not have any issues. No, all of our functions are still resolved because we just made changes in the service layer. So if we now run this, then you can see our backend is running. And yeah, there are still some logs from the previous videos, but in the end it's run. Let's take a look in Supabase. Because in Supabase, we can really inspect all of our database tables, and if we did everything correctly, we should see our table here. So we can go to the table editor here in the sidebar, then we have our public schema, but for some reason, normally our tables would be listed here, for some reason our table is not here. And well, the reason is that normally creating a table in SQL requires you writing SQL. So you need to go to your SQL editor, which you also have here, and type some SQL, hey, create table. If it doesn't exist, this is how it's called like. These are the fields, these are the columns that we can save in the table. We could do that here in Supabase, and then we would see our table, or we can also let JPA generate that. And for that, we need to set one setting in our application YAML file, or actually better in application dev, because here, under the Spring category, we want to set this DDL auto to update. I will say something about that in a moment, but in our production file, we don't want to set it to update, but to validate. What does this DDL auto property will do? If we say update, then JPA will take a look. It will analyze our schema we've defined here in form of tables. It will analyze that with our annotations and then simply create, or rather update the schema if there are changes that have been made in our code. Because normally when you make changes in an SQLDB, you need to run a migration. You need to define, hey, these are the fields that changed. This is how you take the old field, this is how you migrate it to the new field, and so on. But by setting this to update in development, we achieve that JPA does that for us automatically. In production, you don't want that, because in production, this could technically lead to unintended changes being made, because if you leave all these changes to JPA and execute it automatically, then of course, sometimes things happen that you don't want. So in production, we rather want to just let JPA validate that, check if there are changes in the schema being made, and if so, it will throw an exception to ask you, hey, please provide a migration strategy. In development, it's more convenient to let it automatically update this. By the way, of course, in a real production setup, you would also have your own separate URL. So you would have a development database you connect to in your application dev file and your production DB that you set up in production. But let's now relaunch this and take a look in our console, and we get an error. Okay, interesting. Are we perhaps running in the production? No, you can see I'm not running any profile at all. Oh, I am actually. So if I'm opening my environment variables, you can see I've set the Spring Boot profiles active environment variable here to production. So that actually just proves my point, because the strategy here is set to validate, and it noticed, okay, there's actually a change, and we've defined a schema that doesn't look like that on our remote DB in Supabase, so it just throws an exception and it finishes the process. If we switch the active profile to development and we click OK, and we relaunch this, then take a look in the logs. Then, I'm not sure if we already see something here in table editor. Yeah, we actually do. You can see there is our quotes table that has been created. And it's currently empty, but we see our different fields here already. You can see author, content, created at, and an ID. And that means if we now switch to Postman, and here I need to connect to my right port, and we insert a new quote. So we make a post request to our backend, quotes endpoint, we insert a new quote. ID doesn't matter here because that's updated and maintained by JPA. If we now give this some kind of new quote content, maybe this is my first persistent quote, and we send this, we get OK back. We get back the quote that has been inserted in our DB. And if we take a look in Supabase, typically this updates in more or less real time. If not, you can also turn on real time by clicking on real time here. Enable real time, and then wait a little moment, and perhaps reload this. Yes, and there's our quote. We've saved our first row in our SQLDB, first ID, author, content. You can see the created at timestamp that can be parsed. And we could now insert another quote here, send this, then we would get the ID 2 back because JPA has auto-incremented that. And we again, if we go back here, we would again see these changes after reloading this here. Our second quote. So now even if we relaunch our server, which cleared our quotes list before, where we used an in-memory list, if we now try to get our quotes in Postman, so we get our list of quotes, send this, then we get our 2 persistent quotes, despite of us having relaunched the server. So lastly, I actually want to take a look into more custom queries that you don't get from this JPA repository interface that we make our repositories depend on here. So you've seen that there are quite some functions like find all, save, and so on that we can just use as they are. But what, for example, happens if we want to make use of our query, so of our search functionality again? So let's say we want to have a function that searches to-dos, searches quote based on a specific query the client provides. So let's say we take this query and we pass it to our service, command click into the service, make it accept such a nullable query, and then we can say we return if the query is not null. So if the query exists, here we would want to have a query, a database query that searches in our table for quotes that have this, where the content contains this query. Otherwise, if we did not specify a query, we just return all quotes. And while you could, of course, now technically say here after that, you say you filter this based on whether the content of the quote contains that query. Imagine your database table contains 1 million entries. Then you don't want to first load the entire DB into memory in order to then filter based on that. That is why we have database queries, so we can already filter on the DB level. And JPA, in this case, if we now go inside the interface, works with a very specific type of naming. And this is actually not just JPA, but this is quite a Spring Boot standard that inside this interface, as long as we stick to a certain naming convention, we can define database queries without having to write the SQL on our own. So if we just type function and then, for example, find by, you can see these auto-completions, which I think is, again, just an IntelliJ Ultimate feature. But we can, for example, say find by, specify some kind of field from our table that is automatically recognized, find by content, and we say contains. So we want to find all quotes where the content parameter contains a certain string. And we could even say we want to ignore the case. So if we use that one and then take this, pass in a query here, and we expect back a list of quote entities, because multiple quotes could, of course, match that query. And we then go to our service, and we call this function find by content contains ignore case. The query is our query. And we also map these two DTOs. We relaunch this. We make sure here in our controller to check the query format. It is the Q parameter. And we go to Postman. These are our two quotes. And if we say, okay, we define our Q parameter and set this to quote, for example, so we want to search for quote in the contents of all of these quotes, and we click send, we get back both our quotes, because both of these, the content contains the word quote. If we now use something that is definitely unique for one of these quotes, which would be only the number 2 here, so let's say our search query is 2, and I'm not sure if this works because we have a validation running and that there must be a minimum length. Let's quickly turn this off. Is there? I remember we had that, but probably don't have it anymore. Okay, whatever. Let's use Q is equal to 2 and then we'll see what happens. We search. Oh yeah, and it works. We just get our single quote back that has our 2. I must say this is not the most efficient way to search a database, but it's the most simple one. And it shows us how we can define such custom DB queries. And now, of course, not all SQL queries can purely be implemented by specifying this here with this function-like syntax. What you can also do with JPA is you can define your very own SQL code, your very own SQL queries, and then also let it just return your entities. This would also work by function. This one you can now give any type of name. So search quotes, for example, we pass in our query, returns a list of quote DTO, and you then annotate this with query. And then here in the query annotation, we can have triple quotes to have a multi-line query. We can really just define our SQL query. For that, you of course have to know SQL. But we could say select a certain quote Q, for example, from our quote entity table called Q. And then we say where the quote.content is actually where the query, we can say with a colon, so that is how we reference a parameter from this function, where the query, and it's actually a different way. We need to say like, because there is no contains operator, but here it suggests that already. This is, in the end, the equivalent query. So where the content is like a certain pattern, where the percentage is a placeholder for any number of characters, any type of characters, So where our query is in the end just contained. And yes, this would now be case sensitive, but it would almost be equivalent. And if we now, actually not relaunch this yet, but if we now rely on the search function, search quotes, and doesn't that return a list of, oh, it actually returns a list of entity, of course. If we now relaunch that and we go to Postman, search for quotes with our query 2, send this, then we again just get back our single quote because we've now specified our own query. So this is, of course, what you can also do. You can define really, really complex queries that way and still have this type-safe interface here with the JPA. And of course, this isn't everything about databases. We could go really into detail, into different tables, into different types of relations, into migrations, and so on. This gives you a pretty good first overview of what databases in Spring Boot are like. And if you want to learn about all the other stuff, it makes sense to follow this channel now. Because in the next Spring Boot Basics video, we will talk about resources, providing files to endpoints, and also just kind of importing files here in your Spring Boot IDE in the resources folder and be able to use these and reference these in your code. Thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.